Yeah, so welcome everyone to this event. Yeah, AI is a hot topic. You know that this is everywhere. So why shall we have another event? I mean, there are hope and fears, there are expectations. There's a lot to discuss regarding AI. And for a long time, we laughed about the results that have been produced by AI. But now it sometimes outperforms even researchers in its results. So this is why we have another event here, and we focus on AI and its influence on research. And we're very happy to have David Bessis here. So David is a mathematician, so he has been educated in mathematics. He did his PhD in mathematics, then he had many articles. Amongst others, he has an article in Annals of Mathematics. This is the absolute highest journal that exists in mathematics. He also has an article in Invenciones, so if one of this would go, best journal is not enough, he also has a paper in this other really big journal. So he really is a complete scientist in mathematics. But then at some point in his 30s, he left academia and he started a tech company. And this was about 20 years ago. So when AI was not cool, he found AI was cool and he founded a company in AI. But then 3 years ago, he left this company and he is now an author and publishes, and he's really thinking deeply about mathematics and AI. I'm very happy that he's here. Welcome, David Bessis.
Thank you.
Yeah, so mathematics will be somewhat in the center of this discussion, but we will also expand to other parts of science, of course. But my first question is regarding mathematics. So has there been some result of an AI regarding mathematics that surprised you recently?
Well, I must say that maybe for me the most surprising thing is that it's not a specific result, is that AI is getting good at many different areas of mathematics. There are some where you would expect AI to outperform humans very quickly, and some that you would have thought to be more abstract. It's not there yet, it's not exactly at the same level everywhere, but I would say that there is a new feeling among many mathematicians I'm speaking with that there is no clear limit in terms of domains, and even the most abstract, the most geometric ones, look like they can get a lot of value from AI. And this, I must say, was a surprise.
Mm-hmm. So you can read many headlines regarding AI. They really seem to produce a hype. So something like AI cracks mathematical conjecture, or LLMs produce PhD level research. The top physicists have already surrendered to AI superiority. So what is there that headlines? Is there the substance behind that, or is there something that has been even hidden by these?
So there is something that is a bit hard to understand, that you can have at the same time something really incredible, delivering incredible value and doing incredible stuff. And at the same time, you can have an hype on top of that. And I think we're in a situation like that, and it makes it very, very confusing, because you're basically forced to choose one of two sides, which are both delusional in their way. The Luddite side where you believe that this is nonsense and it's not creating real value, just a stochastic parrot and all that. And the AGI or ASI, artificial superintelligence side, that says that humans are nullified by this new technology. I think both of them are wrong. And one way to look at it is to look at the gap between technology and value. It's something that struck me when I was transitioning from science to becoming a tech founder, that there is a gigantic gap between a technology and a product. Mm-hmm. People think of tech companies as being mostly driven by technology. In fact, they're mostly driven by product, by how do you solve a problem for your customer. And what's tricky with the new wave of LLM-driven progress is that LLMs are kind of a miracle that creates a confusion between the technology and the product. If you think about AI, the technical term is machine learning. And machine learning algorithm is something that has an objective function. Let's try to minimize something. And what an LLM does is to minimize the divergence between the output and the expected output. So it's super good at creating the illusion that it's giving you a perfect solution, because within the realm of language, it delivers something that is the top of what you can expect. So because we're so used to using language as a proxy for everything that's meaningful underneath, we get the illusion that it's sorting out everything. But the gap between having a meaningful answer in terms of language and having a functional product in real life outside of language is actually gigantic.
So what would you say, where is AI right now? I mean, as I said, we make fun of the stupid results that AI produces, and if I enter some math questions, will it produce something meaningful?
So it will, among many non-meaningful things, and you will be the one responsible for sorting out the mess. And this situation is far from being solved. In terms of mathematics, there is a way, which is new, to guarantee that the result is mathematically correct, which is to formalize it and to auto-formalize it. So you have to think that there are basically two flavors of machine-driven mathematics. The first one is actually the older one, is formal reasoning, viewing mathematics as a formal game of deduction. You have axioms, you have rules of derivation, and you start from things that you know to be correct, and you derive them mechanically, and you get new things to be correct. It used to be the way machines were functioning in the past. They were doing that part, the rigorous, the one that is based on formal deduction and computation. And in the modern world, this is encoded by the formalization effort of mathematics and using frameworks like Lean. And this guarantees that a reasoning is correct. And there is a more intuitive side of reasoning, which used to be the monopoly of humans. So this is the thing that is done by LLM now, which is to say, based on a kind of fuzzy learning, based on everything he's seen before, and finding patterns and structure in everything it's learned, trying to come up with hallucinations of what might be true. And this is actually how you do mathematical research. You come up with ideas, you're not sure they're correct, and then you use formal computation to check that they're correct. And because we've made progress on the two sides, there is this very new phenomenon, which is something that has only occurred in the very past month and quarters. That is, we're now able to produce mathematical results entirely through machines and to guarantee that the output is correct. So it looks like that you've solved one of the old issues of LLM, which is hallucination. Or I should say incorrect hallucination, because the correct ideas are kind of correct hallucinations. But still, you're a long way from doing what a mathematician does when a mathematician proves the theorem, which is to not just come up with a proof, but with meaning and understanding associated with that proof. And that nuance is something that is very hard to explain, because it's not the way we've been discussing mathematics in the past. We used to think that proving a theorem is everything that matters, but in fact, we're faced with a situation where we can prove theorems and still don't understand them and still don't get any value from them.
So you're referring to Lean, so maybe just for the audience, so Lean is a software that checks proofs in mathematics and as a formalization of mathematical proofs. So this means on the one hand, LLMs can try to find in the literature whether there's a result, but it can also now start creating its own proofs and checking it via Lean. So that's what you're referring to, yeah.
Yes, these are guardrails it's exactly the way you do mathematics when you do research. You come up with an idea, and you try to make sure that your idea is correct. And usually it's not correct at your first attempt, but when you refine it, you adjust it, and iterating using the formalization, the rigorous part of mathematics as a scaffold, you actually tune your intuition to make it correct. And this back and forth between intuitive thinking and rigorous thinking is at the heart of mathematics. And really, we have both parts implemented in software right now.
And so it seems that mathematics has really become a trophy for AI companies. So there's a quote which you have in your blog. It says, "Deep minds solved Go and chess because they are closed systems with certain rules. And next we're going to solve mathematics. Because mathematics is also a closed system, so AI can now do mathematics. So that's the next trophy. And there are AI companies that really want to spend a lot of money just to solve math problems in order to show that they can do it. So what do you think about
so
that?
this is, and I think this is where the hype is starting. And it's extremely hard to argue against that hype, because that hype is built on top of something real and impressive and new and really powerful, and is going to change the world in any case, whether there is hype or not hype. But still there is hype on top of it. And the hype is to say that math is a closed system. It's not true. It's not because you can make sure that a theorem is a theorem and you have proved it you have checked that it's a formal deduction, that you have done the job of doing mathematics. Let me give you an example. If you take probably the most famous open problem in mathematics, that's the Riemann hypothesis. It's something about the zeros of a certain function, and it's supposed to correspond to certain properties on the distribution of prime numbers. The exact statement is not really meaningful for the conversation, but what is important is to say that it's a statement that we think is correct, but is precisely expressed. And if someone comes up with a proof that maybe should be 20 million lines long and checked by a computer, we could say, okay, we have proven that theorem. But mathematical creativity is not just about proving theorems. It's about crafting the language in which you can express these statements. The notions that are underneath, there's the notion of complex numbers, prime numbers, infinite sums, meromorphic functions, and so on and so forth. And these notions were invented to make sense of other problems. And Riemann came up with that conjecture without the help of a computer. Mm-hmm. And he said, okay, this is an important property. I think it is correct. If correct, it would mean that these are the reasons why I think it's correct, even though I cannot prove it. I would say that this is peak mathematical creativity. Coming up with a language, with something that you think is true for moral reasons, because it makes sense to you, and predicting more than a century in advance that is correct. And of course, proving the theorem would be gigantic. There's currently $1 million prize attached to that problem. Mm-hmm. But still, it would be missing some part, and it looks like this part is much harder to implement by a computer, because this other part is not well defined. And this is where the systems we have, especially the formal proof systems that work within the closed side of mathematics, which is the axiomatic side, are not capturing something that has to do with the meaning of mathematics and the intuitions that we come up with when we try to make sense of mathematical objects, the reason why we create mathematical objects. And at this point, there's still a gigantic gap between what machines can prove and concepts they can invent. Mm-hmm. And inventing concept is probably the most valuable part of mathematics. Just think about all the concepts that you know, that you rely on. If you think about numbers, they had to be created by someone. Even if you're a hardcore Platonist who think that God created the integers, 20,000 years ago, we did not have the same notion of integers we have today. So probably there was some work done in between, done by humans.
So what you're saying sounds a bit reassuring in the sense that humans are still much better than AI, because AI can do certain things, but the really big efforts can only be done by human beings.
I'm not sure we should use the word better or worse. Mm-hmm. I think we're different. And the thing is, we're more interested in the human interesting problems mm-hmm. than machines are. They are really good, incredibly good, for good reasons. You know, if you very often when you do mathematics, you know how hard it is to read a paper that's not in your direct field of study. If you try to read a paper by someone else, you take another person in the same math department to try to read one of the paper, it usually takes you what, days, weeks, months, if you try to make sense of a paper. It's very hard. So just imagine what you would gain from reading all the papers that are existing. And this is what the AI is doing. And obviously, once you've done that, you become incredibly good. I don't know how many papers you have read in your career. How many? What do you think?
Not millions.
Not millions? Hundreds? Not even sure.
Yeah, hopefully.
About 100 or 200?
Yeah.
300? Okay. So having read everything that's been written in mathematics and being able to make sense of that and to put together a proof that uses a part from there and another part from another side of mathematics, it's obvious that you're going to do crazy things that humans cannot do. And also the ability to make complex reasonings and to check them line by line using a formalization system. This is inhuman, and there's no way we should think of competing with that. So we used to call these things the most noble parts of mathematics because, coming up with far-fetched intuitions and very complex reasonings, because these things are very hard for humans. But still, we do things that we did not used to think were the hard things. And it looks like these are the really hard things, which is to decide that a problem is important, to extract meaning from it. And it's not going to be an easy transition to change from a world where the value was attached to doing hard things for humans that are better done with a computer now, and changing from that to a world where the meaning making and concept building side of mathematics, which used to be called a bit casual or sloppy or not rigorous, is actually the most meaningful.
Maybe let's also get a bit to the point where it hurts for scientists, because for the moment, there's this AI development, and as a researcher, you could believe for quite a while, I can ignore this. So I can do my research as I did before, and I can just ignore it. And now it seems that there are certain proofs, certain results by AI, which is really on the level of a PhD student or even beyond. So there's also this project of a first proof, which I guess also Martin Heira, one of the Fields medalists, so this is the kind of the Nobel Prize for mathematicians. He was involved in this project. They set certain benchmarks, and a couple of these benchmarks have been reached by AI.
Yeah, there's no hiding from that. It makes no sense to hide from that. The machines are doing things that used to be the monopoly of humans. And it creates tricky questions for science. But I think academics had it coming. There is a dysfunction in academia that is a very old thing. You know that there is this overproduction of very technical results, and millions of papers are written that nobody really reads about. And you could make a career. It's a sad secret, but it's something everyone knows in academia. But you could make a career by being the expert of your own tiny monopoly, being the one person on earth being able to comprehend that. And you could produce a string of paper, one every couple of years, advancing the field that is interesting to you and maybe 5 other people on earth. And because no one could understand what you were doing, you were safe in a way, but that was a bad way of being safe. And this is disappearing. We will look at it centuries from now as a temporary dysfunction of 20th century science, this overproduction of overly technical science, where the barrier to entry to mastering this tiny subfield of science was so high that once you had reached it, once you were beyond the barrier, you were protected from the outside, and then you could continue your own business for your entire life. This is going to disappear. There will be no value in being the one person in the world understanding that technical part of science and continuing to produce tiny things within that thing. On the other end, there is a gigantic opportunity for leveraging this direct access to everything that's been created before, to solve problems that were unsolvable before. One metaphor and one way to look at it is to think about science as a business. And there were many interns positioned in the old business of science, of people where, like little hands, small hands, solving very technical problems, hands-on, and not really caring about the big picture. I think it will transition to something that will be less like that and more about building a strategy to solve a meta problem, a more complex problem. And this creates very practical issues, especially for PhD students. It used to be that you could ask intern-like questions as stepping stones to becoming a more strategic scientist. That, in your career, you start by small technical problems and then you gain confidence and then you... The question is, how do you build a career in that new framework? I don't have a solution. I think it's a very tricky thing. I think it's a very practical, hot question for all PhD advisor in mathematics. You basically run out of PhD problems because the PhD problems are the ones that are solvable. They're made to be solvable with the existing technology so that people can solve them in 2 or 3 years. What do you do? But on the other hand, there will be scientific problems. We will need people to use whatever technology is available to solve these big scientific questions, and we will need to train them. So we will have to find a way.
So when there's a master student in the audience and thinking about doing a PhD in mathematics, or maybe also physics, computer science, what would you say? I mean, does it make sense?
Okay.
Now the title is, will AI do my PhD? So can I just sit down one afternoon and then my PhD is done? Or?
Okay, so there's probably some of them in the room. So I want to be honest. I mean, if you had asked me the question 10 or 15 years ago, I might have already given you a kind of tough answer. The tough answer is there are many bad reasons for doing a PhD. And I think that these bad reasons are becoming worse. So I should insist that these are not good reasons to do a PhD. Reason number one, because you're afraid of the future and you just want to have a protected career path in a protected world of academia where you don't confront the real life and technological change and whatever. No, it's not a stable world. There is no stability anywhere. You can actually turn it into a positive, which is, if there's no stability anywhere, why not do a PhD after all? I mean, if it takes your job as a scientist, it may take your job as any other job, So, but don't look at science as a stable institution. It's going to be in trouble, but it's not going to die. So there's going to be science, but it will not be the science you know. The second bad reason is, and if I'm honest, I think I was a bit, it was one of my own reasons. I had both the bad and the good reasons. I think there is some, when you're a good student, there is some addiction to the prestige system of academia. You get good grades and you get better and you say, okay, I want to get the topmost degree just because I'm good and I can continue being good and I just want to know how good I am. The prestige of academia is in trouble. It's not starting with AI. It was already there. There is a funding issue. There is a profound crisis of the institution of higher education. It's not new and it's clearly getting worse. So don't be addicted to a prestige system that is in trouble. That's a bad idea. Now, there are good reasons to do a PhD. And I think they're still equally good. The most important one is just because you're really curious about what you're studying. You find it exciting. You want to understand that. You want to have profound questions in science. We do science because it's exciting. And it's no less exciting. And AI probably makes it more exciting as soon as you're able to accept that it's going to be disrupted and the prestige system is going to change, but the science itself is still equally exciting. Whatever domain you want to study, there are many reasons to fall in love with any scientific topic. And the second reason, which I think is probably the most profound one and the one that should be the test, is will doing a PhD make you more confident, make you more emotionally, and cognitively able to become a better person? I mean, working for 3 years on a single topic that is hard, that is pushing your limits, it's actually good. There are things you learn when you do that you cannot learn in any other. The ability to sustain an effort, even if you're hitting roadblocks and you continue for month and month and month, and you succeed. If you succeed, it doesn't work all the time, but if you succeed, then it's great. I mean, it's to transform you, and it brings it brings a stability, a vision, and also a sense of transformation. When I was a CEO, I was hiring a lot of people with PhDs because they had that ability to understand how you can bring a problem from point A to point B over multiple iterations. And this is still the same. AI doesn't change anything to that. So the bad reasons are getting worse. The good reasons are getting the same. Do a PhD if you want to do a PhD.
But isn't it frustrating that maybe when I did my PhD, I sat down and I worked for 4 months until I finally got the result, and maybe AI is doing it now in 4 minutes. I mean, isn't it frustrating when you start as a PhD student that you see there's a machine which is much smarter than I am?
So it's not going to be the same problem. If the problem can be done in 10 minutes, it's not going to be a good problem. So the question is, what is becoming a good problem for a PhD student right now? It cannot be like that. Maybe, and you're talking about mathematics, maybe in mathematics it will be about establishing bridges between different fields of mathematics, something much more high level, much more conceptual. I don't know what it will be, but I'm sure there will be mathematicians, I'm sure there will be PhD students, and they will make progress. And the minutes you have a machine that is able to answer your questions within minutes, it transforms the way you look at science. It transforms what you find interesting. Every technology is changing the way we think and the way we attribute value to things. Look at how photography transformed painting. People used to think that because we can make pictures, painting is dead. But no, painting is not dead, and you can actually make a lot of money by being a famous artist right now. But what you do is quite different from what you were doing before photography. It's hard to predict. And it's the reason why it will be the new PhD students that will be disrupting the old professors. I'm sorry for you, but this is going to be the case. Because you cannot anticipate what it will look like, but still it will happen. The future will happen. It will be disconcerting, that's for sure, but it will happen.
For the moment, the interaction with AI is basically, I ask the question, the AI gives an answer. So will there be a point where AI writes its own papers? Just starts thinking and publishes the papers, and it's just completely, the question is done by AI, the answers is done by AI, everything. And who will read these papers? Only AI, or will we read the papers?
Okay, so I think that it will not happen. Not because the technology cannot do that, but the moment it happens, there will be 1 million papers, and you cannot publish 1 million papers in any journal. So you will have an immediate loss of interest for the kind of paper that can be produced by AI like that. So it's a mystery to me, what will mathematical paper look like 20 years from now? I think they will look different, for sure. I don't see how we can. I don't see how we can manage that transition in practical terms. And I must be very honest about that. That's kind of, I joked about you being the one who will get disrupted, but I will get disrupted too. I have no idea what mathematics will look like, but I'm certain there will be mathematics. Mm-hmm. It's a tricky answer, but it's quite sincere.
So it seems for the moment LLMs are really optimized for conversation, right? So it's a chat bot, so I'm talking to some machine. So will there be also other AI which is really more research oriented, more like reasoning, concluding, a completely new AI for research?
I suspect yes, and I suspect that actually we will see fabulous breakthrough in applied mathematics. Because in applied mathematics, there's the bottleneck of making sense of things is not the same. If you want to build a fusion reactor, and you have to design a tokamak that is, functioning well, there are many mathematical and physics problems attached to that. We don't need to understand the solution. We just need to build the machine. So I suspect there will be. This is just an example, but I suspect there will be actual businesses specialized in solving very complex technology problems with systems that have been optimized to not just an LLM, but incorporating some kind of feedback from the actual physical or technology problem they're looking at. And there will be very dark areas of technology. Things that no humans can understand. Things that are not completely produced by science as we know it, as a process of understanding, but things that are just optimized by machines. It will be scary, but again, it will happen, so
So you destroyed already my job in a way. So who will pay for mathematicians if all the results come from a machine?
Okay, I think the question is who will pay for mathematicians is a question you could ask even before AI, because there's some people who think that higher education is useless and we should not pay for it. So what I mean by that is that it's not directly a technology question. It's a political question about the value of education. I would break it down as separate questions for applied math and pure mathematics. And I think it's a good thing for mathematics that there is this new clarity between what is applied mathematics and what is pure mathematics. It used to be that if you study this object, you're a pure mathematician. If you study that object, you're an applied mathematician. That was a bit artificial. Now it will become very concrete. If your job is to optimize something using a mathematical framework so that a machine performs better. For example, you want to optimize MRI so that you get better resolution of what's happening inside the body, sharper images, and you can see things, with capture in real time, better resolution and everything. This is applied mathematics. And you don't need to understand how it's done. It's good to understand if you want to debug some stuff, but you can limit your understanding to the minimum. And you don't need to pay anyone to be a mathematician to do that. You just need to pay someone who is building a nice MRI machine. But that's a product design question that is incorporating some mathematics in it. It could be that it will be led by a product designer who is not that good in mathematics. Now, pure mathematics resembles science in the sense that it's about meaning understanding. The reason why we look at the Riemann hypothesis is not because we really need to make sure that the distribution of prime is the way it is. We are quite confident it is like that. We kind of already know it from all practical matters. But we want to understand it. And understanding is something that is a human notion. Whatever is doable by AI, there is value in understanding it. And there is value in sharing that understanding. It might be that AIs are very good at explaining things, but your own human understanding is a human phenomenon. And it's clear that we will need people to lead the understanding effort. And these people will be mathematicians, even if they rely on very complex machines. And they will be the pure mathematicians.
Thanks God.
You have a job.
Yeah, I still have a job. I'm very happy to hear. Yeah. So in fact, in your blog, you also say at some point that mathematics was sold to human beings as being a very powerful science and you need smart people to do it, and now AI can do many things here. I think at some point you wrote in your blog, mathematicians need an answer now, why they're needed in the future. So can you give a short answer?
So I still think that they need to be smart. There's no. It will never help to be an idiot. You know, it's not because you have artificial intelligence that you can completely eliminate the need for human intelligence. I actually think that it will be more demanding, but more demanding not on the mildly autistic side of mathematics, which the kind of supercomputing aspect of making very complex reasoning. But actually, when you do research mathematics, you know that this is not where it's happening. It has to do with being able to make things simple, actually. Being able to accept your own limitations and compensating these limitations by having a very conceptual view of things, very profound, intuitive view of stuff, making them really tangible through simple explanations for yourself and for others. So I think for me, the best definition of mathematics is one by Bill Thurston, that the product of mathematics is clarity and understanding, not theorems. Clarity and understanding are things that happen in our brains. We need clarity, we need understanding. These are human phenomena. As long as we've not been killed by the robots that will take over, we're here, we want to understand stuff. So we need mathematicians for that.
Sounds good. So maybe I also give the opportunity to the audience to ask a couple of questions. So we have a funny little cube that we can throw to you. So is there a question from the audience to David Bessis? It does not need to be a question by a mathematician. It can also be an experimental physicist. Samuel, here's an experimental physicist.
Just hoping that the student wants to ask a question.
Yeah, so let me start. I'm an experimental physicist, but my question is actually more to mathematics or abstract things. And I understand from what you're saying that there's no proof yet that AI has found for the Riemann hypothesis. There's one thing that we are looking for in physics, actually in theory, which is a security proof for quantum key distribution. Yeah? And so, but it has not been found, and I'm sure there are many people out there trying to find it with AI. Yeah? So what does it tell us that it has not been found?
We don't know. Once we find it, it will tell us something that we haven't found. It could be that we know the conjecture is false. I doubt it. That the proof is very hard. Or that the systems are not just mature enough for that. It's hard to know. This side of question is very hard to answer.
Is there a further question from the audience? Or is there a student being afraid of doing a PhD in mathematics? Oh, there's another. Samuel?
Okay, so I'm also a mathematician, and okay, maybe you are still giving us hope by saying that okay, machines cannot really understand. But I mean, is this just is this what we said 10 years ago, that they cannot calculate or do proofs? Or I mean, you say they are optimized for giving results which we expect. Maybe one can also optimize them in some way for understanding. So isn't there really a barrier there, or yeah, you become somewhere to the point where they really can do what we think is understanding problems?
So I actually think they do understand to a certain degree. I don't think there is anything we do with our brain that is magical, and understanding is part of that. Now, it's not because there is no hard limitation here that they're actually having the same kind of understanding as we have. Our understanding is not just conceptual, but it's also embodied in things it's connected with things we want to do and things we experience in our life. Our own understanding is what we care about. The machine has some kind of understanding, and that's a great thing. Good for them, and good for us that they have some understanding. But we still want our understanding of stuff. So this is why this notion that, the question of whether we're smarter or they're smart, or they're smarter and we're better, I don't really think we should look at that this way. I think they're probably smarter than we are, and they understand things in their own way, but we want to understand things. And our desire to understand things is what makes science valuable for us. And this is not going to disappear. It's not because someone else is understanding that your own desire for understanding is vanishing. And human understanding is something that is specifically human. Even though machines can probably provide answers that will help understand, we still want to understand. And there's no reasonable scenarios where they're just machines and humans are just interacting with machines, and we're not interested in what some other human who may be more specialized and have a bigger investment in that area of knowledge. And this human, might be telling us interesting things. So I think we should look at it this way. Within the human community, we want to understand stuff. And the people responsible for making things understandable for humans, even if it involves leveraging millions of machines, are still scientists in a way. So we should not find reassurance by claiming that machines cannot do stuff. We just should be pragmatically aware that we want to understand stuff, and we're humans, and this creates an opportunity for us.
Thanks for the discussion. I have a question. In your discussion, you most talk about research, but I have more a question about education. You'd mentioned at some point that the problems for PhD students will change because there might be this entry-level problems might break away. But my question is more about what's about like bachelor and master degrees in general, since we're here at the university and most people at the university are not researchers, most people are students at the university. So my question will be like, how will this look like for people who are not going to university not for doing research, but for getting like a bachelor degree or a master degree, and how this will change like the whole structure of the university in general?
So it's an immensely practical question, and an immense practical question, but it's not a profound question. When you look at it, why do you have exams? Why do you have assignments? Why do teachers ask you to answer these questions, to write an essay on that? It's not because they want an essay on that, It's not because they want to. Why when we have primary school kids and we teach them multiplication table, and the teacher asks them, what is 3 times 4? The teacher is not really interested in the answer. They already know it, The answer is 12, okay? And the fact that an artificial intelligence can provide the answer doesn't change anything to that. Now, the thing is, it used to be that you could trust the fact that you had to write an essay, and the essay was unique, and you had to understand tons of things and to develop very advanced skills to be able to write that essay. And you cannot game the system. You cannot produce an essay by entering a prompt and getting an essay in 20 seconds. So this is breaking down the evaluation system through which there was a feedback loop to make sure that you were learning things the way you were supposed to learn. But it's much easier than for research. For research, the question is, we really want the answer to that question. So if a machine provides the answer, then we're in trouble, in a sense, because that was what we were looking for. But for the students, this is just the old way of making sure the student is making progress. This old way of doing that is breaking down, and it's already broken, and no one has fixed it yet. But I guess we will switch to more oral exams, because in a conversation, you cannot fake it. I cannot answer your question by prompting because I don't have like magical glasses that tell me the answer. So I have to improvise it. So I have to be competent in some ways. I think the studies will switch to that, and they will be less disrupted after that.
So maybe a last question. There's a student over here, I guess.
You told us that it's possible to generate answers very quickly, but nowadays we're also bombarding harder and harder problems with more and more computing capabilities. Do you think it's cost effective in the long run still? Because I've heard sometimes it's even cheaper again to just rehire some software engineers or something, depending on the problem.
So I said there was hype on the top of technology, and there is clearly, especially when you look at mathematics, that is, it's kind of the grand prize of, it's supposed to be the grand prize of human intelligence. So all the AI labs want to capture it, and so they want to prove the biggest results and throwing insane amount of resources that are orders of magnitude bigger than everything that's been spent on those problems before. So this is not meaningful. On the other hand, I do not see this objection as a viable long-term objection to the profound disruption caused by AI. You can expect orders of magnitudes in terms of efficiency, energy efficiency. We're just seeing the beginning of that. So there is a conjunctural overspending, but the trend is clearly that more and more things will be done by AI in the future. If you're looking for a reason to not look at this revolution, I think it's a bad reason.